Hello there and welcome. In this lesson, we're going to talk about static classes, static members, and also namespaces. So what is a static class? A static class is just a class that cannot be instantiated. It means that we cannot create an object out of it. And you may be wondering, why do we even need this kind of class? Usually we create objects out of classes. They're supposed to be blueprints. But we can have static classes that will be used as utility classes. So we don't need to create a specific instance of it and then use its members or its data. We just want to use its functionality and we don't need more instances of it. We can just have this one instance, this static class, and we can use its functionality everywhere in our code. A very simple example are all these classes that I kept mentioning. For example, the file class, and this is a built-in class. It comes with C#. We used this in the previous lesson to write to files or read from files. But this by itself is a class. And if we hold Control and click on it, it will show us the way this class is actually structured. So this is a built-in class. That's why you see all of this information and it has many different methods. But if we go over here, you can see that it is a static class. And this is the reason why we can just use it everywhere in our program. We don't need to create an instance out of it and it won't allow us. So if we try to do file, new file, it will say cannot create an instance of the static class file. Because it's static, we cannot have objects of it. We can only use it like this and use its static methods. Now, inside of a static class, if we go to this one, all the methods and all the members should also be static. So you can see that all the different methods are static as well. But we can still have static methods inside non-static classes, and for this we're going to create our own static class. Let's say we have some kind of logger, and we're not going to create it inside this file. We're going to create a new file, a new script, logger, and inside it's going to be a public static class logger. And we're going to have one method, public static void log, and we're going to provide a message. And we're going to print this message. You know what? Maybe let's use the knowledge we learned. Let's just have this written into a file. So let's have a path, logs text, and provide a message over here. So it's going to create a file named logs. Let's also make it append, so it will actually append not all lines, but append all text. So it will add to the text and it will not override the text, right? We can also create this line break. We want to break the line after the message. So now it will log in, it will create this new file. And this is just a simple utility class. And now, if this was not static, if it was a regular class, it means that each time we wanted to log something, we should create an instance, new logger, and then use this instance to log the message. But this doesn't make sense. We don't want to create an instance each time. Imagine we need to log something 100 times. We don't want to create an instance each time we want to use this functionality. Also, imagine that inside we have some data that should be global to this logger. For example, public static int logs count. Maybe we are counting the amount of logs we generated, and then we simply increase the logs count after adding a log. Maybe we want to create some kind of way to limit the logs and then check if the log limit has been reached. so we cannot log or create a new file, right? Something like that. Maybe we also have a public const string, and we actually save this as the path. So then we can use this as well, just to be a bit more organized. But maybe we have this logs count. If we keep it like this, so if nothing is static, then we create a slogger, we print this event, and the log count will become 1, right? Because we increase it to 1. Maybe it's 0 at the start, and then we increase to 1. But if we want to log something else in a different place, maybe in some other class, then we need to create this again and use this new instance to create the log. But this time, it will increase the log count to 1 again because it's a new instance. So the logs count was increased to 1 before, but it was increased for this object, for this instance. It was not increased for the other instances. That's why it doesn't make sense to use this kind of logger and to instantiate different objects. We can use this as a static class, having a static method, and also have a static integer for the logs count. So everything is static besides this const because we don't change it. This is permanent, right? We can also rename this to, because it's a const, just so it will be easier to know that this is a const. So everything is static, and it means that we don't need to do all of this. We can simply say logger log. And now it will increase it to 1, but statically inside of this logger. Okay, it will increase it to 1, and then we can use this again in a different place, maybe inside of our Pokédex. Then it will increase it to 2, and then we can use it in a different place, then it will increase it to 3. Because it will all happen in this one static logger. And it's like a singleton. There will only be one logger, and the data will always change inside of this one static logger. We don't need instances of the logger class. And that's why we use static, okay? And also we make this static, not just so we can access it, but so this data will be a part of the static class and it's not going to be erased because we are not creating new instances, right? We can also access this data. We can have more data as well. So this is a very classic example for why we need static classes. Now, if we print this, let's just remove this from here, but let's print this. We're going to see a new file, this logs file. And inside we can see this is the message. And at the moment, the logger will have a logs count of 1, and maybe we want to check some kind of limit if logs count is bigger than, maybe we also have a const logs limit, and then we say that we only want to allow 10 different logs or maybe 100 logs. Then we can say if logs count is bigger than, is smaller than the limit, then allow this to happen. Else we can give a warning, maybe logs limit reached, or maybe it will be smarter to create a new file, right? Maybe instead of doing this, we want to maybe change the path and create another file. So instead logs path, we're just going to have some kind of logs backup txt. So all the logs that were not inserted into this file will go into a new file, or maybe logs1 or something like that. So that's a very specific example for a static class. Usually we are using this for utility classes. We have different methods that do different calculations, especially calculations that we want to use very often, right? Maybe addition, maybe specific string manipulations, maybe we want to format something. So we have all of these methods inside of a static class, and then we can just use this class very easily because we don't need to create an instance out of it to use its methods, right? So we talked about static classes, we talked about static members, and members can be these methods or any other data inside of a static class. It can be very useful, but again, if you don't need anything like this, you don't need to use it. You can use this when you actually need a static class for your program. The next thing I want to talk about is namespaces. Namespaces are very useful, especially when you have big projects and you don't want to mess up the code. And this is also something that you can see in a lot of libraries, a lot of external packages that you have access to. They will usually have namespaces because they help have some kind of organization inside of the code itself. For example, we may have this logger here, but maybe we have a very big application or a very big game, and we're going to have different loggers for different aspects of the program. So we can create a namespace, and to create a namespace, we just need to surround our entire class with the namespace. We're going to say namespace game logging. And now we're going to take this entire class and we're going to place it inside. So this namespace basically means that this logger class is inside of some kind of, let's say, imaginary folder named game logging. So later we can also have another logger that will be inside of maybe not game logger, but engine logger, right? Maybe some kind of logger that will deal with the engine aspect of your program or your game. So then when you want to access it and you want to use logger, if you use this like that, then you can have many different loggers, especially if they are static, right? We talked about the fact that we cannot create an instance out of a static class, but we can have more than one logger. Even though they're static, we can still have more than one logger. So maybe we want to have a logger inside the engine department that will deal with different engine related things, but we also want to have a logger inside the game department. And when you use this logger, how will you know if it's the one from the gaming department or from the engine department, right? How will you know? For this, when you start to write this down, you can see over here the namespace, game logging. And usually you will also see this using keyword that basically means that you're using this namespace and you can access the classes that are inside of this namespace. Then you can do whatever you want, but maybe you want to use the logger that is inside the engine logging namespace. Obviously, we did not create it, but if I take all of this and I paste it over here, so now you can see that we have all of these issues, and that's just because we basically have a duplicate of this logger class. And it kind of makes sense because we cannot have two classes with the same name. But if we add a different namespace to this logger class, it will work. So if we change this to engine, then we're not going to have a problem, even though we have two classes named logger. Now each one can be a bit different, we can have different members, but usually we are not allowed to have two classes with the same name. But if we have a namespace that is different, then we can have different classes with the same name, because this will be under the engine logging namespace and this will be under the game logging. Maybe we can be more specific. Maybe we can name this Mike, so this is the developer, and this will be David Dev. Maybe all of my classes will be under this namespace and all of David's classes will be under this namespace. Because maybe I don't know David well, or I don't know what classes belongs to David. Maybe tomorrow morning he will create a new class named Game Manager. I don't know about this, right? I don't know what David is doing in his own time. He will create a game manager, and maybe I will also create a game manager in a different day. If David already had a game manager, and I would try to create my own game manager, I would see some kind of a problem. It would tell me, you cannot create a game manager because this class already exists. But because this game manager is under a different namespace, it means that I can create a class with the same name because it's under a different namespace, and it's not going to give us any kind of problems. Because later, when we're going to use this game manager, I'm going to say Mike Dev game manager and use my own logic. And when David wants to use his game manager, he's going to say David Dev. Oh yeah, because of this game manager. So David will use this thing and I will use this thing. Obviously, I can also use the game manager by itself, but then it will not know which one it is. So I can simply do a quick fix using this or using this. In my case, I'm going to do using Mike Dev. So you're going to see this at the top of the actual class, and you're going to know that you're using this namespace. So game manager is the game manager that is inside of this namespace. This is my namespace. We can also hover it and you can see the full path. MikeDev.game manager. This is my game manager. This is David's game manager, and we can have two classes with the same name, but he will do his own thing and I will do my own thing, and we are in this same project, right? It can be a huge project that 100 different developers are working on. So I don't know all the developers. I don't know all the classes. I don't know which classes already exist or not. But because I'm using my own namespace, I can use any class that I want or give any name that I want. So it's like a tag, okay? You're tagging your classes with your own specific namespace. And this keeps things organized. And of course, it's better this way to work with other developers, so each one can have its own logger, its own game manager, and everything can be structured. Obviously, when you're going to see public libraries and APIs, you will always see some kind of namespace, and sometimes you can't even create public libraries if you don't have a namespace, because imagine you're using two libraries from different developers, and one developer will provide you some kind of class or method, but another library that you're using will have the same classes. It's going to give you conflicts. But because each one of these libraries will have their own namespaces, this will not be a problem and you will be able to use the logger. So sometimes you will have these errors of the logger not recognized. You're going to use this and then it's going to say that it's not recognized. Maybe you're missing this using namespace, so you should go to quick fix and add using. In Unity, for example, we can use UI components like image, and then it's going to tell us that it doesn't know which kind of image. So it will tell us use using Unity UI or something like that. I don't remember the exact namespace. We also have Unity, have engine, something. So each one of these are namespaces that we're using. So then the actual class can be recognized, so it will know where it belongs. Okay, so that's all for static classes and static methods, and also namespaces. It's very important. It's a good practice to keep everything structured, especially if you want to work with more developers and if you want to share your code, you should make sure that you have your own namespaces. So all you need to do is take your entire class. It can also be for different classes, right? We can take this Pokédex and we can say namespace Pokemon project. We're going to take this entire class. And now it's a part of the Pokemon project namespace. Then we can also do this for Pokemon class. I think there is a shorter way. Maybe find, not sure. So let's do it manually. Pokemon project. So you're using the same project, the same namespace for this class as well. Okay, so now both these classes are inside the Pokemon project namespace. And if I ever want to use them, obviously I can use them locally, but we will still see the namespace. Because if tomorrow I will have a new Pokemon class, I will know that it's a part of my project. Or I can be direct and just say Pokemon project Pokédex. So this is why we should use namespaces. Let's just move it like this. So I'm just hitting the tab button and it will move everything to the right. I like when everything is organized. So that's all. Thank you for watching. You can become a subscriber. If you're still not subscribed, you can leave a like. You can also ask me anything in the comment section. So I'll see you in the next lesson.